Probability is defined as the measure of the likelihood of an event or outcome occurring, which is another way of saying, what is the chance of something happening? It is all about the certainty, the uncertainty, and the prediction of something happening. Some events are impossible, others certain to occur, and many possible but not certain to occur. Probability is simply the chance or likelihood that something will happen. When a coin is tossed, at a cricket match for example, there are only two possible outcomes, heads or tails. If heads is called, we can say the probability of the coin landing on it is 50%, or 1 in 2, half. If you threw a die, what do you think you'd get? Say you wanted to get a 4. We know there are 6 possible outcomes when you throw the die, of which only one of them can be a 4. So we could say your chances of getting a 4 is 1/6. This is a probability line. Starting at the beginning of the line, we have impossible, which is 0. If something is impossible, this means just that, it will never happen. Next along the line from impossible is unlikely, which is used for talking about something with around a quarter of a chance of happening. Next, we have equally likely or even, meaning it could go one way or the other, like a coin toss. Likely would mean a 3/4 chance, and certain means that something will definitely happen, so this is a 100% chance, or a probability of 1. So where would our 1/6 chance of getting a 4 on a single roll of a die lie on this? The probability of an event cannot be more than 1 or less than 0, because it can either happen or not happen. We can also use decimals or percentages to show this. We're going to have a look at an experiment that James and Maya are doing to learn a bit more about probability. They're each to throw a die 10 times to see what the probability of it landing on any of its numbers 1, 2, 3, 4, 5 or 6 is, and record the results on this table. Before we look at the results, let's understand some terminology used when talking about probability. A random experiment is an experiment that can be repeated a number of times under set conditions for which the outcome cannot be predicted. The experiment James and Maya have just done is a random experiment because it is a matter of chance what number a die lands on. They do not control the results. A trial is what we call an experiment that is carried out. So, a trial has just been done. The sample space of a trial is the set of all the possible outcomes that can occur. In this experiment, James or Maya could have rolled a 1, 2, 3, 4, 5 or 6. So the possible outcome each time the die is rolled is either 1, 2, 3, 4, 5 or 6. An event is a specific outcome or a specific set of outcomes. In this experiment, the event could have been to throw a specific number like 4. A favourable event is when a specific desired outcome is achieved. So if we wanted to throw a 4 and did, this would be a favourable event. If we threw a 2 instead, it would be an unfavourable event. Moving on, you're likely to hear the words theoretical probability and empirical probability. The theoretical probability of an event is exactly what its name implies. It is the probability of events that come from a sample space of known equally likely outcomes. For example, if you wanted to throw a 4 on a die, you know your chances are 1 in 6, or approximately 16.67%. This is a theoretical probability. In other words, it is what should happen. The empirical probability of an event is estimated by observing results of actual experiments, or what did happen. If you wanted to know the probability of the number 4 turning up when a die is rolled, you would have to roll the die a large number of times and see how many times 4 turns up. We have a simple formula for calculating the empirical probability of an event occurring. To calculate an empirical probability, divide the number of times a favourable event occurred during our experiment by the total number of trials done. Let's have a look at the results of James and Maya's experiment now, and find some probabilities using this formula. James had told Maya that he would roll a 1. This is a favourable event in James's trial. He rolled the die 10 times and threw a 1 twice. So the empirical probability of throwing a 1 would be 10 was the total number of trials done, and 2 the number of trials where the favourable event occurred. So the empirical probability of rolling a 1 is 2 over 10, and we can say that James found that the probability of rolling a 1 was 0.2 or 20%. Maya said she would roll a number greater than 4. This is a favourable event in Maya's trial. During her 10 rolls, she threw a number greater than 4 twice. Let's calculate the empirical probability of throwing a number greater than 4. Why would it be that we had the same chance of throwing a single number, a 1, as we had of throwing either of two different numbers greater than 4, a 5 or 6? It is important to remember that the empirical probability doesn't reflect the actual chance of an event occurring. It reflects the number of times that the event occurred in a trial. The empirical probability of an event comes closer to the theoretical probability as the number of trials becomes larger. So if James and Maya had carried on throwing the die all day, their probabilities would have been closer to 1 out of 6 for James and 2 out of 6 for Maya.